All right, section 3.3 was all about standard form, which was our ax plus by equals c, where a must be positive and not a fraction. So if you end up trying to write some equation and a is a fraction, nope, a needs to be a positive whole number. One of the first things we learned about standard form was how to identify the x and the y intercepts of an equation. And we did that by pretending the other part didn't exist. So if I wanted to find the x-intercept of this equation, I'm going to cover up the y part, that minus 4y. Goodbye, pretend it's not there. And then my equation would read 3x equals negative 24. From there, if I wanted to know what the x-intercept was, all I need to do is divide by 3, so that's negative 24 divided by 3, and that leaves me with x equals negative 8. So my x-intercept is at negative 8. If I wanted to write that as an ordered pair, that'd be when x is negative 8 and y is 0. So that was the part we pretended the y didn't exist. Now, to find the x-intercept, guess what? I mean the y-intercept. We pretend the x doesn't exist. And if we do that, we end up with negative 4y equals negative 24. Divide by negative 4. And you have negative 24 divided by negative 4. And that ends you with a positive 6. So if I were to write that as an ordered pair, that was when x was 0. We pretended it wasn't there. And y was positive 6. And that's how you can quickly find your x and your y intercept. Now, if the problem asks you to sketch a graph of the equation, you're going to do the same thing and now just plot those points and connect the dots. So once again, to find the x-intercept, we pretend the y doesn't exist. So that would be 2x equals 8. We divide by 2, and x would equal 4. So on the x-axis, I put a big old point at 4. To find the y-intercept, we pretend the x doesn't exist. And I'm left with negative 4y equals 8. I divide by negative 4, and I have y equals 8 divided by negative 4, that's negative 2. So on my y-axis, I have a point at negative 2. And then I just need to connect those dots to draw that line. So if we need to graph, we just find the x and the y intercepts. Another thing we talked about for this lesson was how if you're given an equation in a different format, you can make it look like standard format, which is what some parts of this section want you to do. So the format that we are in is slope-intercept form, and it's asked us to put it in standard form, which means aka we need to make it look like ax plus by equals c, aka the x and the y need to be on the same side. So that's what I'm going to do first. I'm going to start by gathering my x and my y on the same side, which means I have to move this negative 1/2 x. I have to move it to the other side using an opposite operation. So I'm going to add 1/2 x to both sides. So, and I want that to be first, so that's going to be 1/2 x plus y equals negative 10. And now this is where the part that we do not want our a value to be a fraction comes into play. Right now it is a fraction 1/2. We do not want that. We want it to be a whole number. So the easiest thing we can do is multiply the entire thing by that denominator of 2. The 1/2 times 2 is just going to leave us with the whole number x. Then we multiply the 2 times the y, 2y equals negative 10 times 2, negative 20. And there we go. Now we have a leading coefficient that is not a fraction, just by multiplying by what was in the denominator of our fraction. And we did it. We got this y equals mx plus b format to look like standard form. The last big part and big idea of this section is applying it to create equations in standard form. So here's our scenario. Keisha is catering a luncheon, and she has $30 to spend on a minimum of cheddar cheese, on a mixture of cheddar and Swiss cheese. We want to know how many pounds of cheese can Keisha get if she buys only cheddar, and what about only Swiss? We're going to not do the next part. What linear equation in standard form can she use to model this? So ax plus by equals c is great for these real-life scenarios. When we know a total amount, she has $30 to spend. That's how much we have in total. That's our c value. We have $30. And then we have two things we're comparing. We've got this cheddar cheese and this Swiss cheese. Right now, we don't know how many pounds she can buy. So those are the things that are unknown, is how much she can buy. But we do know that cheddar is $3 a pound and Swiss is $5 a pound. We can use variables to represent what we don't know. So we don't know how much cheddar, we can use an X. We don't know how much Swiss, we can use Y. But we do know that cheddar is $3 per pound and Swiss is $5 per pound. So we could simply write that as 3x, $3 per pound of cheddar, plus 5y, $5 per pound of Swiss, equals 30, because that's the total amount that we have. And now we have set up our equation. And we know that the x represents cheddar, the y represents Swiss. So let's apply that. If we wanted to know how many pounds of cheese can she get if she only buys cheddar, that means when we only have x and we don't have y. That's like when we cover up the y. We don't have it. That would mean 3x equals 30. We divide by 3. X would equal 10, which means she could get 10 pounds of cheddar. If we wanted to know how much Swiss, that means we don't want any cheddar, and we do the same thing but reverse. And that would be 5y equals 30. We divide by 5, and 30 divided by 5 is 6. So y equals 6. She could have 6 pounds of Swiss. And those are the linear equations that we use to model that, knowing that x represented cheddar cheese and Swiss was represented by y. The next section that we learned was section 2.4, parallel and perpendicular lines. We learned that parallel lines have equal slopes, 100% the same number. Perpendicular lines had what we called opposite reciprocal slopes. And in short, we used the phrase a flip-flop, which means that they have opposite signs and a different fraction. So an example of two perpendicular slopes could be positive 3 over 2 and negative 2 over 3. They have opposite signs, check, and they are a flip-flopped fraction. That means that they are perpendicular to each other. So when we're practicing this, some of the times we are given a slope and asked to write a new line, like in number 15. It tells us to write the equation of the line that passes through the given point, the point that they give you, and is parallel to a slope. Well, they give us this line, and so we can see that the slope of it is 1/5. For this equation, we're going to do this in slope-intercept form to practice. So if I need to write it in slope-intercept form, I know that a parallel slope is also going to be 1/5, because we know that parallel lines have the same slope. And now I'm going to use this point that they give me, and this is if the problem asks you to be in slope-intercept form. You can start with your slope-intercept form, y equals mx plus b, and substitute in what you know to help you find that b. We know that our point is 5 comma negative 4, where negative 4 is the y. We know the m is 1/5. We know the x value in the coordinate is 5, and we're trying to find that b. So now 1/5 times 5, you can pull out your calculators and do it, but 1/5 times 5 is just 1. So we end up with negative 4 equals 1 plus b. If I subtract the 1, negative 4 minus 1, check your math, come over here. Negative 5 is our b value. So we know our b, we know our m. We can write our equation y equals 1/5 x minus 5. if it asks you for slope-intercept form. If it asks you for point-slope form, or if it doesn't specify, you can use either. But the next example, let's review point-slope form. This says write the equation of the line that passes through the given point. Okay, we got a point, x comma y, and is perpendicular to the given slope in the given line. Well, this slope is -2/5. If we want to be perpendicular to that, then I'm going to need to change my sign, so I'll become a positive, and I'm going to need to flip my fraction, so that's going to become 5/2. So my perpendicular slope is now +5/2. And if the question doesn't specify what form you need to be in, you can write it in whatever is easiest for you. If I see a point and I know the slope, I'm going to write it in point-slope form. Y minus y1 equals m times x minus x1. And I'm going to do my opposite, y and y1, or y1 and x1, and plug in my slope. So that's going to be y, and then I want the opposite of y1, which the opposite of -3 is +3, equals m, which is now 5/2, times x, and then I want opposite x1. The x1 is -6, so that would be +6. And that would be my equation, and I would type it in and leave it just like that if they don't specify what format it needs to be in. The next type of problem you're going to have is determining whether the pair of equations are parallel, perpendicular, or neither, which means we need to know the slope of both, and then we can compare them to determine if they have a special relationship or not. Our little tip we had is if you want to find slope from standard form, it's the -a/b, where the negative means opposite sign. So let's look at the two lines that we have. We have y equals 2x plus 1, and we have 2x minus y equals 3. Let's find the slope of both of them. The first line is in slope-intercept form, and in that format, the number in front of the x is the slope. So here we can say that the slope is 2. The second line is in standard form, 2x minus y equals 3. So I'm going to need to know what the a and b values are. The a value is 2, it's the number in front of x. The b value is the number in front of y, and in this case it's a minus y. There's not a number there, it's a 1, so that is a -1. Now I can use my quick little formula, m equals -a/b, to find that slope. -a means opposite a. Well, a is 2, so that's going to be -2. b just means straight up b, -1. -2 divided by -1 is a +2. So would you look at that? This slope is 2. This slope is also 2. Those two slopes are exactly the same, which means that these lines are parallel because they're exactly the same. Let's do the next one, number 27. The two lines that we have are -2x plus 5y equals -4 and y equals -5/2 x plus 6. All right, the first line is in standard form, which means we'll need to identify the a value and the b value in order to find the slope of -a/b. So let's figure it out. The a value is the number in front of x, that's -2. The b value is the number in front of y, that is 5. So if I put that together, my a value, my -a, means opposite a. If the a is -2, I do the opposite, that is 2. The b value is 5. So my slope is 2/5. Let's find the slope of the next one. This is in y equals mx plus b, slope-intercept format. So the number in front of the x is the slope. Here, the slope is -5/2. Now it is time to compare these slopes. Let's see, are they the same? No, they are not the same. So they cannot be parallel. To be perpendicular, they have to be a perfect flip-flop, where flip means we change the sign, so like positive and negative, and flop means we flip the fraction. Let's check it out. Are they opposite signs? One positive, one negative? Yes, there's not a positive written here, but it might as well be there. It's not negative. Okay. Second part, are they a flopped fraction? 2 over 5 to 5 over 2? Yes. So are they a flip-flop? Yes, they are, which means these lines are perpendicular because they are a perfect opposite reciprocal, which we learned to call a flip-flop. They have opposite signs, one positive, one negative, and their fractions are reciprocals, which means they look like they have been flipped upside down. And that was section 2.3 and 2.4.